We have looked at hypothesis testing from the perspective that we calculate test statistic and we compare it with critical values. Now, the alternative to this is that instead of calculating critical values, we actually find the p-value of our own test statistic, and that p-value will tell us how much evidence we have for possibly rejecting the null hypothesis. So p-value is also called conclusiveness index. It can also be called weight of evidence or attained significance level. And more generally, p-value is the probability, assuming that null hypothesis is true, of a test statistic value equal to or more extreme than the actually observed value. Very small p-values are strong, meaning strong evidence to reject null, and this is because small p-value indicates that the actually observed data are very unlikely, assuming that the null hypothesis is true. So looking at the same thing in picture form. Now, if there is a specific distribution from which the data comes, and then we marked the observed point somewhere on the x-axis, then all the weight of the probability on the right-hand side tells us how likely this point is when compared to the whole distribution. So in statistics, usually when p-value is greater than 0.2, we say that there is no evidence to reject null hypothesis. So assuming if this green part here has value 0.2 or more, it means that this point is still significantly close to the most likely observations in the distribution. If p-value is somewhere between 0.2 and 0.1, we used to say that there is weak evidence. So we would still be inclined to accept null hypothesis. If p-value falls within 0.1 and 0.05, that's where we would say that there is some evidence. So depending on the problem, depending on the confidence level you want to keep, depending on how strict you need to be in the test, you may or may not reject null hypothesis in this case. If your p-value falls between 0.05 and 0.01, this is strong evidence for hypothesis rejection. So that means that you may already be pretty comfortable saying that null hypothesis is pretty unlikely, so we can reject it. And finally, if p-value is less than 0.01, that's very strong evidence, so that's the case where you will always, under any circumstances, reject null hypothesis. The way how we calculate p-value actually depends on whether we have one-sided or two-sided case. In one-sided case, we always look at the given observation versus just one side of our distribution. So we may be either on the right-hand side here, look at the p-value on the right of that observation, or we may be in here and then look at the p-value accumulated on the left from our observation. And so then the p-value will be the probability that the statistic value may take values smaller than that negative side in here or bigger than the positive ones here on the right hand side. And these kind of values are easy because this is how we express cumulative distribution function. So it's the probability that given statistic is less equal specific value. If we have this p z greater than z, so it's 1 minus probability that this capital Z is less equal small z. So we can simply use the distribution tables which contain CDF values to calculate this. And for the two-sided case, we have to actually combine, and we consider that half of the p-value is on one side and half is on the other side. So the total p-value is actually, for instance, twice this one. So 2 times probability z greater than z, which translates to 2 times 1 minus p, z less equal z. And once again, this one can be read from the tables.